Okay, in this session, I'm going to explain about the transient analysis of RLC series circuit. So to analyze this, let us consider a series RLC circuit. So this is a series RLC circuit. Which is controlled by this switch here, and the switch is closed at t is equal to 0. DC voltage here, this is R, L and C. So this is a series RLC circuit. The current is circulating in this loop, that is I of t. Okay. Here in this transient analysis of RLC circuit, I am going to find the expression for I of t, and I am going to find the I am going to draw this waveform for I of t in different cases. So first, any transient analysis, if you want to do that analysis, first thing here is we need to draw the circuit at t is equal to 0 minus. So at t is equal to 0 minus, this circuit I can draw like this. So at t is equal to 0, the switching action is done. T is equal to 0 minus, the switch is in open position. So resistance and the inductance, normally it is under steady state condition from minus infinity to 0 minus or 0. The circuit is under steady state condition. So the inductance can be replaced with the short circuit and the capacitance can be replaced with the open circuit. So this is the circuit for at t is equal to 0 minus R, and the current that is flowing through this is I naught, that is equal to IL of 0 minus. The voltage across this capacitance is V naught, or it is nothing but Vc of 0 minus. Since no current is flowing because of this open circuit, this I of 0 minus, this current is I of t, at t is equal to 0 minus, this is I of 0 minus. So here, since it is open circuited here, so no current is flowing through this. So IL of 0 minus or I of 0 minus, that is equal to I naught is equal to 0 amperes. 0 amperes. Now this one, it is not charged. Initially the current that is flowing through the inductor is 0 and initial voltage across the capacitor is 0. That is V naught is equal to 0 and I naught is equal to 0. That we need to consider here in this analysis. And also no charge is initially is there, so V naught is equal to 0 volts. So Vc of 0 minus is equal to 0 volts. And we know that the inductor doesn't allow the sudden changes in current. So whatever the current at t is equal to 0 minus, the same current will be present at t is equal to 0 plus also in the inductor. That is IL of 0 plus is equal to IL of 0 minus, that is equal to I naught, that is equal to 0 amperes. That means the current in this loop current is nothing but this current, that is IL of 0 plus is equal to 0 amperes. And also, since the capacitor doesn't allow the sudden changes in voltage, Vc of 0 plus is equal to Vc of 0 minus is equal to V naught is equal to 0 volts here. So finally, at t is equal to 0 minus and at t is equal to 0 plus, the currents are same here and also the voltages are same across the capacitor. So I can rewrite it as I of 0 is equal to 0 amperes and V of, this is, let us consider it is Vc of 0 is equal to 0 volts. Okay, these are the initial currents and initial voltages. Now for t greater than 0, draw the circuit. So this is the voltage source and the switch is closed for t greater than 0. This is the resistance and the inductance can be replaced like this. This is the current I0. Since it is 0 amperes, we need not to place this current source here because it is 0 amperes. Anyway, I am indicating like this. And also the capacitance can be replaced with its equivalent circuit like this, and this voltage is V0 is equal to 0 volts. It is initial voltage. So this is the equivalent circuit for t greater than 0. This is the resistance, this is the voltage source, and this is an inductance, it is a capacitance, and this is the current that is flowing through this loop. So consider KVL here, apply KVL. Now after applying the KVL, this will become plus or minus, it is plus or minus, and this voltage from here to here is plus or minus, it is plus or minus, it is plus or minus. Now if I apply the KVL for this loop, it is plus V minus, it is I of t into R, minus the voltage across this one is VL of t, and this is VC of t, plus or minus it is VC of t. So from here to here it is minus VC of t is equal to 0. It is plus and it is minus. Current limiting terminal I am taking here, so it is minus.